Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, we are going to talk about ionic bonding. So, before we start talking about ionic bonding, you must know what are the different types of chemical bondings. There are three types of chemical bonding you need to know. The first one is the ionic bond, which is the bond that's formed between oppositely charged ions. Normally, you can find this between metals and nonmetals. And then the second one is the covalent bonds, and covalent bonds are formed when atoms share electrons in their outer shell so that each one of them can reach the full outer shell. It occurs in nonmetallic elements and compounds of nonmetals. The third type is the metallic bond, and in this type of bond, atoms share delocalized electrons. It's usually found in metals and alloys. So now let's move on to talk about ionic bonding. And when we talk about ionic bonding, we must start off by talking about ions. So what are ions? Ions are formed when electrons are transferred. So ions are charged particles. They can either be single atom or group of atoms. For example, single atom like we find in sodium, one of the alkali metals, group 1 metals. When they lose one electron, they give you an A plus, or the ions with one positive charge. A group of atoms, example, something like nitrate, NO3, which has one negative charge, or SO4 as sulfate, which has two negative charge. So the ions can be either one atom, a single atom, or group of atoms. So when atoms lose or gain electrons, they form ions. They are trying to reach or to get to the full outer shell, similar to the noble gases. Atoms with full outer shells are actually more stable, and the electronic structure of the ions are called the stable electronic structure. So in order to reach this stability, atoms can either gain or lose electrons. So when you look at metals, group 1 and 2 elements, for example, they only have one or two electrons in their outer shells, so it's much easier for them to lose this electron, and then they're going to form positively charged ions. On the other hand, if you look at group 6 or group 7, where we find the nonmetals, because it would be easier for them to gain electrons in order to reach the full outer shell, so they tend to gain one or two electrons and they form negatively charged ions. The interaction between this positively charged ions and the negatively charged ions will form this ionic bonds. You have to know that there is a specific number of electrons that an atom can actually lose or gain in order to reach the full outer shell. So if you look at group 1 elements, you're going to find that they always lose one electron to give a positively charged ion with +1. And a group 2 elements, because they have two electrons in their outer shell, they tend to lose these two electrons to give you 2 plus ions. Group 6 elements, they can gain two electrons when they take part in ionic bonding, and they form two minus ions, negatively charged ions. And then group 7, which are the halogens, they tend to only gain one electron to give you -1 ions. So let's have a look at the ionic bonding. So we said that ionic bonding comes from the electrostatic interaction between negatively and positively charged ions. So when metals and nonmetals react together, the metal atom will lose electrons and they will form positively charged ions. The nonmetal itself in the reaction vessel will gain that electron or the electrons that the metal has lost, so they will form negatively charged ions. The electrostatic interaction between the oppositely charged ions will lead to the formation of what we call the ionic bonding. We can represent the ionic bonding using the dot and cross diagram. in your exam. It's almost one of the questions that you will see either in IGCSE or GCSE chemistry is that they're going to ask you to draw a dot and diagram, a dot and cross diagram, either for ionic bonding or other type of bonding. So let's have a look how to draw this type of bonding. So as an example of ionic compound is sodium chloride. So when you draw this diagram, you only need to think about the outer shell. The inner shells are not important when you draw the dot and cross diagram. So when we have sodium and we draw the outer shell of sodium, we know that sodium is in group 1. That means sodium has only one electron in its outer shell. So we draw sodium and we draw the one electron in the outer shell as a cross. And then we have chloride, chlorine. So we know that chlorine is group 7 elements and it has 7 electrons in its outer shell. So we're going to draw the electrons of chlorine as dots. So there are 2, 4, 6, and then there is the 8th one. And then the sodium will lose its electron and the chlorine will gain the electron. Sodium will then form an ion, positively charged ion, after it lost that electron. And chlorine will form the chloride, the negatively charged ion, where it will now have 8 electrons. So we're going to draw the 7 electrons of chloride as dots, and then the extra electron that came from the sodium as the cross. Now we have a positively charged ion and a negatively charged ion, and the electrostatic interaction between these two can lead to formation of the ionic bond. So what about, so this is sodium chloride. So what about if we have elements which have like 2 electrons in their outer shell and another one that has 6 electrons in its outer shell? Can more than one electron move? Yes, we can represent it in the same way. So let's have an example for an element from group 2, which is magnesium. So magnesium has 2 electrons in its outer shell. And then we have oxygen, which has 6 electrons in its outer shell. Then the 2 electrons on magnesium will actually, you can represent both of these, both of them will be transferred or will be lost, and the oxygen will gain both electrons. So now we have 2 ions, one for magnesium, no electrons in the outer shell, and then the oxygen, which is going to have 6 electrons. So magnesium will form the 2 plus ion, oxygen will form the 2 minus ion, and then the electrostatic interaction between these two can lead to the formation of the ionic bonding. Now let's move on to talk about the structure of the ionic compound. How do they look? So ionic compounds contain only ionic bonds. And the ionic compounds have a regular lattice structure that's called the giant ionic lattice. The ions will form a closely packed regular lattice arrangement, and there are very strong electrostatic interaction between oppositely charged ions in all directions in the lattice. So if we look here on the left-hand side, you can find the lattice structure of sodium and chloride. Each chloride atom or ion is represented with the green circle, and the sodium with the gray one. As you can see that there is an electrostatic interaction between the oppositely charged ion that works in all direction. That makes the structure look like the packed structure here, a regular lattice arrangement. This is called the giant ion. So what are the properties of ionic compounds? So ionic compounds would have high melting and high boiling point. The main reason for that is due to the strong bonds between the ions in the lattice. So we have positively and negatively charged ions, which have strong electrostatic interaction that works in all directions. So that makes the interaction between the ions very strong, and that means that we need very high energy, high temperature in order to break these bonds and overcome the strong attraction force. When solids, um, the ionic compound, when they are solids, they do not conduct electricity. The main reason for that is that they are held together very closely. We don't have any ions or electrons that can carry the electric charge. However, if they are molten, if we melt them, then as we can see